Greetings. I am, I guess, hosting Astro Cafe for the first time. My name's Kirsten, Kirsten Pedersen. Yeah. Anybody new tonight on the Zoom call or down at the Fairfield Center? Okay, looks like everybody this evening is a current or past member. So that's great. I think for tonight, I've got a few things that we're going to talk about. As we all know, there's a really exciting total lunar eclipse happening on Thursday and very quite late on Thursday. The eclipse begins around 9 p.m., but it doesn't actually conclude. It goes through various cycles and it doesn't actually finish until about 3 a.m. in the morning. And I think it hits totality around midnight. Um, but Lauri, I guess, will update us on what's happening up at the center with respect to the total lunar eclipse this week. And I've put together a presentation um, with some assistance from David on various parts. And I'm hoping to show that presentation tonight. It's a bit of a prelude to presenting it actually next Thursday as part of our NOVA program, which is sort of the new observers, the people new to visual observing program that a few of us are currently delivering up at the center. And just coincidentally, Lauri has very graciously agreed to do a presentation about the NOVA program tonight, just so everybody can get a sense of what that's about and how it's going and that kind of thing. So we've got a couple of presentations for tonight. Um, in addition, Natasha, you mentioned you have an item. Dave Payne has some photographs he's going to show us. And is there any other items that anybody else would like to raise later on the call?
Kirsten, Gary here. Could Lauri give an update on the big grant that these guys that FDAO just got? Or have you done that already?
Kirsten, you can talk about that too.
Okay. Yes, we can do
Sure.
that. We
Okay,
can
great, thanks.
between Lori and I, we will give
Yeah.
an update about that. Um, okay. Perhaps, Lori, we can do that when you give sort of the update about the center
Okay.
a little
Yeah.
bit later on. Okay. So maybe to start, Lori, would you be okay to um, start your NOVA presentation?
Okay. Well, the problem will be is if I can share it. So let's see. Yes. Okay. Does that come up?
Yeah.
Oh,
Yes.
fantastic. Okay. Yay. I never know. Okay. So I will put this in slideshow mode here and we can do it from there. Okay. So Nova has had a checkered history and we are now kind of just getting going on it. But this is the an acronym for New Observers to Visual Astronomy. And if I kind of go back to what was done earlier is quite a while ago, like over a decade ago, the Prince George Center made a NOVA program. So they put it all together and did it for their group. And the and that was being done kind of over quite a bit of time. Sometimes other centers kind of got a hold of it and did it for their center. I know Calgary was doing some things. I think Nova Scotia was doing some things, but it was all over the place and everybody was just taking things and changing it around, and there was no consistency at all to the program. And so the centers asked national and directly the EPO committee, the Education and Public Outreach Committee, to lead the charge to revamp this program to be something that was up to date and would be working for the entire kind of country. So as kind of said that it was nine different lessons, and Toronto did definitely add their own things. There were some included extra topics, and everybody had a bit of a different price structure for whether or not, for some people just had it completely for free and other people were charging, and it was kind of a bit of a mess. So that's why they wanted to get this sorted out a little bit. So the EPO took this over just kind of at the beginning of the pandemic, or just into the pandemic, just about 2022 or so. And as it says here, the original package used overhead transparencies. That's how that's how old the program was if anybody can still remember overhead transparencies. So we wanted to create more comprehensive materials, create a cohesive program, add topics to it because we wanted to put more in there. We needed to do an online version of the program because the original one was completely it was only directed towards doing it in person. And we wanted to have a support or update system for it so that it could be kind of continually worked on. So the NOVA program is kind of split into two categories. And in fact, right now, we're really only on the left-hand side. We have 12 core modules so that you can see the ones. Now, this is what is here now, and we still are going to definitely do some revising. So 1 and 2 was kind of the orienting yourself in the night sky. Quite a bit of where we are, what was happening to what was going on in the sky, things like declination and right ascension and altitude and azimuth, and they were quite tricky to do. And we found out through a couple of different groups that have done this that those are a little bit too tricky for just a totally novice person, and we may have to do some changing of that. And then we went into some constellations and seasons. And then we made a module called seasonal observing, which was, so for the 4 seasons of the year, we just did this with our group that we had. And we did the winter constellations, but in fact, there's all 4 seasons and they all are a little bit different depending on what's there. And then last week we did some equipment, which David was kind of leading because he had written some of the written part of it. And so we were talking about the different kinds of telescopes and some helpful tools. We actually were supposed to do those 2 last week, but because we had such a fabulous actual observing night, we actually had it was clear. The other 3 nights that we've had were completely clouded over. We saw absolutely nothing and couldn't do any observing. So when we got there, everybody saw Mercury, which was just great. And then we went in, did the little program. Then we went back outside again to actually do some observing. We had the telescopes out. They were using their sorry, I'm going to have to just leave that for now. They were using planispheres, and so sorry, guys. And that was the kind of the 1, 2, 3, 4, 5, 6. Oh goodness gracious, sorry. The six modules that we were going to do. And then that was part 1. And then we're going to do the second part of it in the fall. So that is where there's 1 module on the sun and 1 on the moon. Solar system structure, solar system observing are 2 different ones. 1 on stars and 1 on deep sky objects. And we're going to try to do those as a part 2. And then, when we were actually developing it back in 22, 23, we actually put in some of these additional modules because we wanted to do things on radio astronomy and cosmology and light pollution and astrophotography, and all of these different ones were being done, and they are they have been made. They certainly need a lot of revision, but they have been done. Um, so this is kind of what the topics are are that we're trying to do, and each one of the each one of the programs has different kinds of materials that are provided. So there's a center material for just basically things, but the presenters get a full module manual that goes along with the structured PowerPoint presentation. So there's all these modules that get both a PowerPoint and a PowerPoint and a manual, and then the student materials. So those are those two, and then the student materials, they each get a set of materials as well, and extra resources that that is kind of other things that they can look at, things that they can go back to, that kind of thing. So that's so that the students get one kind of set of resources and the presenters get another. And what we were doing was having a presentation, and this time we've been doing it with five people, a team of five. A thank you to David Lee, Kirsten, Chris Purse, Jeff Pivnik, and Ida Van Schuckman from the FDAO, and we have and myself. So there's six of us, I guess, and we have been compiling by doing parts of them and pulling those together. And then there's activities that we've done. And then we was supposedly doing the outside observing, but we've been lucky enough to be up at the center and have done a planetarium program on the nights when it was really cloudy. We just opened up the planetarium and we did as much as we possibly could in there. Still nothing compares to when you can actually get out and be right underneath the sky. So that's just kind of a little bit of an outline of what we're going to do. Part 2 is going to be probably 6 weeks. We'll do 1 unit per week, and will be sometime in the fall of 2025. So if any of you are interested in either taking the course or helping with giving the course, that would be absolutely fantastic. We'd love to have that on. So there's a couple of people. I'm not sure whether not Susan, are you here? I can't see who's in. Is Susan Grady here tonight?
Yes,
Susan
I'm
is
here.
part of the course.
I'm here.
Hi, Susan. So Susan is one of the people that is taking the course, and I'm not sure whether there's Kathy Kozoil. Kathy, are you here as well?
Mm-hmm. And Wyman
Okay.
is here as well.
Oh, and right. Yeah,
Mhm.
Wyman and his
Sandy.
wife and
Yeah.
Sandy are here are as well. So they might want to have a little bit more give a little bit more information because they're right in the thick of it. And I've got a little bit more where we told them right at the very beginning that they were guinea pigs, and that we were doing a pilot program, and that we would make mistakes, and that we would have to do revising and editing and all kinds of things. But they've been very patient with us, and we're coming up to this final night on Thursday, and so we're going to be doing our final little section on tips and tricks and hints for observing, and a little bit of a review, and then everybody gets to go outside to see the solar eclipse or the lunar eclipse. So that's what we're doing. So Susan, or Wyman, or I don't know whether or not you have anything that you'd like to add.
I'm sure I'll say that I'm quite enjoying it. There's a lot that I have not got my head around. But at minimum, when I hear the rest of you talking, at least I've got some vocabulary with a bit of understanding of what the words mean. So that's helpful.
Yeah.
I have not been dedicating any time in between the classes to really absorb it because I've got another project going on, but I'm very happy to be there. So that's
Thank you.
what I have to say.
Wyman, did you want to say anything about this? Maybe not. Dave
Lauri,
Payne, you got your
Lauri, I think, yeah,
question?
David has a question. Yeah.
Dave's got a question, yeah.
Okay, I unmuted to finally the button. Yeah, it was great.
Oh, sorry, there's
Oh.
Wyman. Okay,
Sorry,
I'll come back to you, Dave.
Yeah,
Yeah.
it's great. It's a great general, overall thing. There's so much stuff to learn. Yes. So yeah, my wife really enjoys it. She's really into it too. It's great.
Yeah, I've got greater appreciation for all of you. Like, it's just amazing. I thought, you just look up and you see some stars, but there's actually so much more to it. And to try and learn it all, it's quite something. But I'm going to miss it, once it's finished on Thursday. And I look forward to the fall classes.
Oh, good. Thank you.
Yeah, yeah.
Good. Okay, Dave, did you have a question?
Oh, no, it was just for round 2.
Comment. Oh, yes.
Would it be better to have it in spring and summer when there's not so many clouds?
Possibly we're into looking at that for sure. The thing is that the observing then becomes light, so you can't really see anything until later on, and I don't think people would probably like to be in the course from 10 to 9 to 11. So I don't know. Well, we can think about you're quite right. We talked about the whole thing about clouds. Yes. It's either clouds or light, it's one or the other.
Yeah.
So yeah. Yeah. I think Carl, okay, Shanae?
Oh, okay. So part 2 is in the fall. Is that then open again, or is that the same cohort completing?
We'll open it back again for other people. Yeah.
Oh, great. And how do we sign up? You'll tell us in the cafe?
Yeah. It will be. We actually used the sign up. Actually, for this one, we used people just emailed me and kind of paid through like just an email transfer, and it was done within about 2 days. Like people just signed up and got their names in, and it was all full in about 2 days. So yeah, we'll let people know ahead of time.
Thank you.
Yeah. Did I see Carlos? Did Carlos have a hand up at one point?
Yeah, it's CJ here. Yeah, I just
CJ,
wanted
yeah,
to.
sorry, yeah.
No, that's all right. No, I just wanted to contribute because while we are talking about education aid, I had just created a little aid on Google Earth to represent the size of the solar system to better understand the size of the solar system. So can I just hijack your screen for a little bit?
Yes, I can totally take this off here. Hold on. Where is my stop sharing? Where is my stop sharing? I've lost it.
Usually is it at the top?
Oh, here. Just a minute. Let's see if I can get this back again. Hold on. I can't find this. Oh, there. Oh, okay.
Yeah, you're good.
I'm good? Okay.
Yep.
There we go.
So does everybody sees Google Earth? Okay, so
We do now, yeah.
yesterday I was reading an article on the observatory, and I realized that the dome of the observatory is 14 meter in diameter, and the sun is 1.4 million kilometer in diameter. So the dome is actually exactly 100 million times smaller than the sun. So I created a little HTML file that shows the size of the solar system compared
Oh.
to the neighborhood.
That's cool.
So here you have Jupiter with the real distance from the sun and scale distance 7.79 kilometer, and then real diameter and scale diameter. So that means that the Earth right here would be about the size of a grapefruit, about 12 centimeter, and the moon would be about 4 centimeter in diameter, 3 meters away. So that helps to understand it a little bit. If you're standing
Yes.
output
Mhm.
of the observatory, then you can picture if you hold a grapefruit, then you have the exact ratio between the Earth and the Sun and the distances. So I will be more than happy to send it's a KML file, it's a little file that contain the orbits and then the information. So I'll be more than happy to share
Oh, we'd
it.
love it. We'd certainly use it
Yeah,
for
maybe
sure. I mean, I
maybe
can,
send it to Joe
yeah.
or something. Yeah.
Send it to who?
Send it to Joe, I guess, or put it in the chat.
Oh, yeah.
Yeah.
Yeah, okay. I don't know if I can in the chat. I don't know if I can
Oh,
share.
you actually have a KML. Oh, okay. Maybe send it to Joe. Maybe he has a way of putting it into the website.
Okay, yeah. So I'll send it to Joe, and yeah, I thought it was pretty neat to have a compared to our region the size of our solar system to scale. Anyway,
Mhm.
Well, I can
that's all I
see,
had to
I mean,
say.
what I'd love to do is to take it, like, is to have kids that are at various places, like, on the island or up island, and they actually take a proper comparison of size and do something with it and say, okay, we're up here where Saturn is, this kind of thing. So that would be
Yeah, and
great. Yeah,
Jupiter is about 1.4 meter in diameter, so about
fantastic.
the
Yeah,
height of a student, something like that.
yeah,
So that
yeah.
helps people to understand the size of the solar system.
Thank you. Well, certainly we'll use that for sure. Thank you.
Okay, so I'll send it to Joe, and thank you. That's it.
Okay. I think I'm done. Kirsten?
That's great, Lauri. Thanks very much for that.
Ron.
Total lunar eclipse. I'm not going to touch anything with respect to the participants. Okay, so what is a lunar eclipse? So it's interesting in that similar to a solar eclipse, it also involves shadows, but differently, of course. And basically, what happens is it's an event that happens when the moon moves into the Earth's shadow, causing the moon to be darkened. So essentially, the sun, earth, and moon need to become exactly or very closely aligned with Earth in between the sun and the moon. So the Earth is between the sun and the moon, and it's the shadow that comes from the Earth that obscures the moon. And so what's interesting, and the photo here credited to David Lee is when the Earth is positioned precisely, and it's got to be precisely between the moon and the sun. That's when we get the total lunar eclipse effect. When it's in between the moon and the sun, but sort of semi or not completely aligned. That's when we get things like a partial lunar eclipse. But when that shadow falls upon the surface of the moon, it dims it, and at times it turns the lunar surface into a striking red or orange color. And we're going to talk more about that next slide. But the other thing that makes a lunar eclipse a little bit different from a solar eclipse is that a lunar eclipse is visible from approximately half the Earth, unlike a solar, which has a very specific and defined kind of path of totality. So this visual credited to a fellow by the name of Pete Lawrence from BBC Sky at Night. This kind of shows that alignment effect, and I've got another visual after this that kind of shows the penumbra and the umbra a little bit in a little bit more of a refined way. But there's different phases of a lunar eclipse, and the moon first moves into the outer part of the Earth's shadow, and that is called the penumbra. And it's actually a very difficult thing to see, but we have a simulation that will show that a little bit more effectively. But the lunar eclipse actually starts to become clearly visible when
Sorry.
Would you prefer I under order or over order?
When the moon moves into the inner shadow,
Over
which
order,
is
because you like
sort of the
selection.
dark
Or you can, because we're gonna have steaks for supper tomorrow, so
inner shadow called the umbra. What's interesting is the sunlight that passes through the Earth's atmosphere, through that shadow in the umbra, when it reaches the moon's surface, that light, it lights the moon's surface very dimly, but it's really interesting because it's the wavelength of the light that is getting through the Earth's atmosphere that's actually reaching the moon. So interestingly, our atmosphere actually scatters short wavelength light like blues and violets and dissipates it. So it doesn't actually make it through the shadow to reach the lunar surface like the long wavelengths like red and orange. So here's another visual kind of showing that I guess the penumbra and the umbra, and you can see like that narrow kind of stream, which is that dark umbra. So it's again like the lunar eclipse is only noticeable once the moon kind of enters that umbral stage. But it does have a very pale shadow called the penumbral phase, which we'll also see shortly. So in terms of the phases of the eclipse, like we've got the penumbral eclipse, which begins around 8:57, and then that partial eclipse. So the umbral stage begins around 10:09, where it starts to become a visible dark shadow moving kind of up along the surface of the moon. The full eclipse, the maximum eclipse is around midnight, and then it ends, and then it kind of degrades again. So it takes about 6 hours to kind of go through these full phases. But this is in Victoria. In other parts of the globe where the lunar eclipse is visible, the times, of course, will be different. Um, David, did you want to run?
Yeah, if you let me take the share. In the
Okay.
meantime, I think Ben has a question for you.
Okay.
I think you touched on it with the sun being filtered by Earth's atmosphere a bit, but I've always kind of wondered, when we have a solar eclipse, the moon actually blocks off the sun, and just so you just see black with the corona of the sun around it. And I've always wondered why on a lunar eclipse you still see the moon, it's just filtered with the red light.
Hmm.
Why doesn't it become completely blocked off like in a solar eclipse?
Oh, I see what you're saying, Ben.
Yeah, it's a
There's
very
Uh,
there's
simple question that
there's
I feel like I should know the answer to, but I don't.
well, there is a lot of light
there's
involved. Like if you
there's
look at
no
the
atmosphere on the moon.
well, that too, but I mean the
Okay.
the
Okay.
shadow is very broad. I some light gets through, right? It's
So it's
just it's
just
just
it's just that. It's just
I think so, yeah, because the light is quite scattered, right?
yeah.
Okay, so I have the simulation. I did this in Stellarium. I there's a way of locking an object in Stellarium, so I basically locked it and did a video of it. And a couple of things to note in the top corner here, there's the magnitude of the moon. I'll play it a couple of times, but you'll notice that at this moment, this is just before penumbral, just before, and the magnitude is minus 12.9. So you'll see this dip, as this goes through its process, that magnitude will dip and then it will come back and around. The other thing you'll notice is, and you have to watch for this, the shadow will come up like this. First of all, you notice this kind of wave of not absolute darkness, but you'll see there's a dimming that goes across the face of the moon here. That's the penumbral shadow. And then it will be followed by an extremely dark umbral shadow, and it'll go across the face, and then you'll reach totality. Just before midnight, you'll reach totality. But the interesting thing is when the moon reappears, it comes from this side. And I won't answer the question right now, but um, it is different, and people will always ask, well, how come? Well, we'll answer the how come in a little while.
How
So
speeded up is this?
I just put it on run. I compress almost 6 hours into about a minute.
Oh,
That's how fast it's running. And watch it, watch for it. See the penumbral? And then umbral coming up. Totality. Comes in from the side.
I never realized that it comes back from a different point like that.
Well, it does and it doesn't. I'll explain.
Okay.
Okay, we're going to loop it again. Now watch for the magnitude. If you get a chance to look at the magnitude at the top, you see it'll start dropping. Dropping, dropping, dropping. At totality, it hits -1 instead of -12, which is bright. And coming back. Okay. So let's just stop it right here. So the question first of all, did people notice the magnitude dropping? So it goes to like it's not it's approaching zero, so which means it's getting dimmer, right? Uh, the bigger the minus number, the brighter it is. So it starts off at like -12. So that's the first thing to notice. Did people notice the penumbral? I don't know if the monitor is very good to show that, but I can kind of see it. I can see that kind of gray cast running over. That's the penumbral. And then you'll at just before midnight, the partial eclipse happens, and that's when the umbral shadow touches the moon, and then it takes a little while, and then it reaches totality just before midnight. And then I didn't show the last 30 minutes. It's really just the penumbral shadow retreating. Okay, so can anybody answer that question?
Field rotation.
What was that?
Field rotation.
I don't know if that's an appropriate response to that.
Okay.
The moon's
The
moving.
well, that's a partial answer.
the Earth, the moon isn't aligned. The orbit of the moon isn't perfectly aligned with the shadow.
Well, that's
So
that's the result. That's the result of the fact that we're all moving. So yeah, Dave, you're right. But it's because of the fact that the Earth is moving and the moon's moving as well. So there's this kind of movement going on. So it won't occur in the same spot. It won't enter back into the same spot. Okay, did you want to take it back, Kirsten?
Okay. Okay. All right. I think we're gonna move ahead here. So one of the interesting questions that comes up every month or comes up is why is there not an eclipse every month? Like we know that for a total lunar eclipse, the moon has to be in full moon phase, and it needs to be directly aligned in between the sun and the moon. So the question is a good one, is like, why do we not get a total lunar eclipse once a month? Because of course the moon is orbiting around the Earth and the Earth is orbiting around the sun. And if everything were kind of perfectly aligned all the time, this effect would be happening all the time. But the interesting thing is about it is that the Earth is tilted relative to Earth's orbit around the sun. So it's this tilt, the tilt in the moon's orbit. That's the reason why we have occasional eclipses instead of one every month. So basically, most full moons just miss the shadow, like they simply pass above or below it. Now there's a little video here, and we'll see how this works. Hopefully you'll be able to see it and hear it. Great. Back on, all right, everybody still see the presentation okay? Okay,
Yep.
great.
May I ask
Okay,
a question, Kirsten?
yeah.
It's Shaunik.
Hi, Shawnee.
Is there any alignment with our ability to see the lunar eclipses and the equinoxes? Because it seems to be about the equinox now. Is that not right?
Mm,
Not quite sure there's a correlation there. The eclipses only occur during the time when there is a full moon. And I'm not sure if that,
I mean, when the sun, you know what I mean? Like it's
yeah, I think
when the
Lauri,
Earth.
Lauri, do you know the answer to that? I should know the answer, but I don't.
Yeah, if I could join in. Oh, sorry.
Go ahead.
Because
Go ahead.
the ecliptic of the moon is tilted 5 degrees compared to the ecliptic of the Earth. So that means that most of the time the moon is above or below the Earth when the Earth is casting a shadow.
Oh, I see.
The moon, the full moon has to coincide with the node of both ecliptic.
Yeah.
That's right. It
Yeah.
has to match the lunar node, doesn't it?
Yeah.
So
Because
they don't.
I don't think that there's anything that is specific to the equinoxes.
Yeah, I don't think there is either.
Okay. So you don't find them more frequently at this time of year or in September. So that would be March 21st and September 21st.
I don't know. I don't know. I'd have to look at that. I don't know. Is there anybody else that knows anything about that? If Randy was here, he'd know.
Yeah, Randy would know. I don't, but
yeah.
Okay.
I didn't see anything about that particularly. I mean, the point is exactly as CJ mentioned, and that little video we just watched that NASA produced. I mean, it's really you know, the proximity to the ecliptic is, and I would say like there's 2 points, like 2 nodes around that, but due to the 5-degree tilt, once the moon actually gets into the path of the ecliptic, precisely, that's when and it hits a full moon, that's when we'll get a total lunar eclipse. The further away from the ecliptic it is, it becomes a partial, which happen quite frequently, actually, partial eclipses.
right.
I think you're right, Sonia, but if the sun is aligned with the ecliptic,
Yeah.
and or in March and October, but if at other times of the year, the Earth is misaligned with that. But if the moon is also misaligned the same amount, then you will get an eclipse any time of year. So it's really doesn't have to do with the alignment with the ecliptic. This has to do with the alignment of the Earth and the moon and the sun.
Yes. I did just check, you know, what do you call it? The AI in Google, however reliable. And it said there's no correlation because of, they don't say why, but I'm sure it's what you're saying, that those, the elliptical slightly different, right? Okay, thank you.
There's a really nice little video that National Geographic has put together that kind of ties everything together. We think this might be a nice thing to show, just to give an overview of a lunar eclipse.
A lunar eclipse happens when the Earth blocks some or all of the sun's direct light from reaching the moon. This cosmic event only takes place during a full moon, which happens once every 29.5 days, or the length of one full orbit of the moon around the Earth. So why don't we have an eclipse every month? The moon's orbit is tilted a few degrees in relation to the Earth, so the Earth, moon, and sun don't always align. When the Earth does eclipse the sun, it casts two types of shadows on the moon. A larger shadow, known as the penumbra, and a smaller, darker shadow, known as the umbra. There are three types of lunar eclipses. The first is a total lunar eclipse, when the sun, moon, and Earth are in perfect alignment and the moon falls within the Earth's umbral shadow. Total lunar eclipses are the most striking of the three types because they turn the moon a sunset red. While shorter blue wavelengths of light are scattered outward by the Earth's atmosphere, longer red wavelengths are refracted or bent inward toward the moon, making it appear red. The brightness of the moon's red glow depends upon how much dust and clouds are in the Earth's atmosphere. Following volcanic activity, ash can block out enough light to render the moon a darker red or even near black. A partial lunar eclipse, the second type, occurs when the Earth, moon, and sun don't perfectly align, so only part of the moon passes into Earth's umbra. Earth's shadow appears very dark on the side of the moon facing Earth. Last, a penumbral lunar eclipse occurs when the moon passes through Earth's penumbral shadow. The event is so subtle that most people don't even notice. The moon will appear just slightly darker than normal. Lunar eclipses occur up to 3 times a year and can be observed from the entire nighttime half of the Earth. Unlike during a solar eclipse, it's safe to look at the moon with the naked eye during a lunar eclipse. It is only because of the distances of the sun and moon from the Earth that we are able to witness total lunar eclipses. As the moon inches away from the Earth each year, one day, billions of years from now, the moon will be too far away to fall completely within Earth's umbral shadow. Until then, we can occasionally enjoy seeing our own planet's shadow cast upon the largest object in the night sky.
Great. Back to the presentation. Okay, and just for a point of reference, David recommended a certain website called Mr. Eclipse.
Yeah, so I think most people know who Mr. Eclipse there is. Fred Espenak. I don't know how long he's been running this website, but it's been a long time. Kirsten, if you don't mind scrolling down a little bit, I just want to talk a little bit about some of the features. So he tells you about, in general, what kinds of photos you can take. So there's the wide shot, and keep going. There's these trail shots and multiple exposure shots, and keep going. And he also gives you an idea, what focal length you use and how much field of view and how big the moon is. So that's kind of critical depending on what you're trying to do. And further, okay, now here's the exposure guide. This is the one that I always use, but it's become a little bit moot in some ways because of digital cameras. Because if you don't have it right, you can just adjust it on the spot. When we used to shoot film, you kind of bracketed a lot and you wanted to have some good starting point. So most of us would go to the lunar eclipse exposure guide, and they have ISO ratings to use depending on what kind of film you're using, and then what f-stop on your lens you're using. And then there's also this interesting thing. If you go down a little bit further, this thing called the Danjon value. This has to do with how dark the skies are, like if there's particulate, and you can use those as a means of adjustment because if you got a lot of particulate in the air or it happens to be a particular dim situation, then you're going to have to increase your exposure. But again, for most of us nowadays, because we're digital, it's kind of moot, but it's always good to use these just as a starting point. Great. Thanks. Thanks, Kirsten.
Okay, awesome. So that's the website reference. Okay, and so we're actually about to show a few samples of eclipse shots that have been taken by Victoria RASC members over a number of years. And we just thought this would be, and again, this is a presentation that we think we're going to be delivering next Thursday, this coming Thursday for the lunar eclipse event up at the center. So we wanted to showcase some beautiful photography of our Victoria RASC members. So this one was a really cool one, and of course David can speak more to it because it's his photograph. But it was just really cool to see something other than the pure, beautiful kind of blood red, you know, usual kind of eclipse, total eclipse image. This one was just really beautiful with this kind of, you can see kind of on that top kind of left crescent corner, that blue kind of turquoise effect. And again, like it's a visual kind of artifact, I guess. I don't know if that's the right word, but I guess like as light is passing through not only Earth's atmosphere, but I guess if enough light passes through Earth's ozone layer, the blue doesn't actually scatter as much because the ozone layer absorbs a lot more red light and it allows that blue light to kind of pass through. So it just very, very unusual effect. David, anything to add?
Yeah, I'll just tell you a little story. I think most of us are astrophotographers who try to emulate what is real. And often we are often fooled, I guess, or often scratching our heads. Should it really look like that? And I'm sure Dave knows what I'm talking about. You photograph something, you think, well, what color should it be? Right? And I certainly thought this when I photographed this. It's an extended exposure. That's the first thing you're going to notice because of the fact that there are stars in the back. So if you expose long enough, you'll get the star pattern in the back. It's also tracked, otherwise it would be smeared. But when I saw this and I was processing it, I thought, blue ain't supposed to be blue. It's supposed to be red, right? So I thought, oh, I wonder if I need to color correct this out because it's blue, right? It's not supposed to be blue. So I read later, after the fact, that in the upper stratosphere, where the ozone layer is, if light passes through that layer, it actually passes blue. It doesn't pass red like the other lower layers of the stratosphere. So this is an ozone turquoise teal color, which is actually real. It's totally real. So this is authentic. And the other thing that I really liked about the shot was it actually makes it look very three-dimensional because it doesn't normally look like that. So yeah, it's cool. It was a nice surprise.
Is this not a better reason for the term blue moon than the typically?
I don't know. I think culture would probably beat me out on this one because of the other reasons for blue moons.
Is a blue moon like when a full moon happens technically in 1 month? Is that
Yeah,
Um,
twice, twice in a month.
twice a month are blue moons, and sometimes I can't remember who it was, but they said that there really are blue moons. There are moons which are kind of bluish. Oh,
interesting?
Dave's saying three, two, three. I don't know what Dave is gesturing.
Great.
He's laughing.
Okay. Okay, so here's one that was taken by Joe Carr in 2007, and it's a composite of phases of total lunar eclipse that was taken, I guess, from Mount Ptolemy.
Yeah,
Um,
the nice thing about this one is there's various types of ways of depicting lunar eclipses. Some people just do the solo shot. I've done a mix myself where I've done a collection of phases, and they actually can be quite surprising. There have been years when the beginning is very the moon doesn't look normal, so to speak. And again, totality, you often get that weirdness in totality where sometimes you get that blue rim. So everyone's different. But what Joe's tried to depict here, and this is a very early composite, this is from 2007, and he's tried to show the phases, not in its entirety, but enough to show you totality in the center, but a nice shot. Now, one thing to notice is there's a huge challenge in getting these shots because when it's going into the umbral state, you still got, or even penumbral state, you still got a very bright lit area of the moon, and then the dimmer area is quite different in terms of exposure. So in the days of film, I know this is not film, but in the days of film, this was extremely difficult, and you had to choose. And the way I used to do it is I would let it lean one way on one side of the eclipse, and then once it hit totality, I'd lean on the other side on the backswing when it came back. But
David, did you notice that in this shot, the Earth does leave in the same direction that it came from?
yeah, this one, yeah. But then again, this is
David's saying
detached.
maybe not.
But
Unless
then again,
Joe rotated the picture.
yeah, yes, because in this case, these images are detached. This is not real life, right? These are individual shots that have been comped into the shot, right?
But I'm thinking Joe wouldn't have rotated it on purpose. But
I don't know. Maybe Joe can speak up.
I was going to say, Joe, speak up.
Is Joe there?
Sorry, I'm busy taking notes. What were you asking?
Joe, we were noticing that the entrance and exit of the moon in this shot appeared to be different than what we saw earlier. And we're wondering, did you rotate the moons in this composite to make it that way, or is that just the way it turned out?
I don't think I rotated this, no.
Okay.
Joe, were you using a tracking mount or just a tripod?
That's a good question. I have no idea.
Yeah. It's hard to know,
It's
really.
obviously a composite. I just want to caution people that the moon does not look that large in the sky when you're looking at it through the city.
I never thought of mentioning that, Joe.
Little fingernail, you know.
Well, actually, isn't that the real size there at about the number one or about the 1 o'clock area there? Isn't that the real size of the moon there? That little dot?
Oh, the little dot? Oh, yeah,
Yeah.
probably.
Yeah, I guess there is. I can't quite make it out on my screen, but
Oh, yeah, that is the moon. I didn't even think of that.
I usually try to do that with my composites to put a natural sized image in there. Yeah.
Yeah. Okay, cool.
Has anybody ever used a neutral density filter to try and help with the washing of the brightness, washing it out?
I thought of doing that, but then I thought about it. It's relative, right? I don't think it really buys you anything,
Right.
unless you want a really long exposure to get background stars. I don't think it buys you anything.
For
Okay.
visual observing, I have used a polarizing filter with the moon, which works
Mhm.
quite well, and it would certainly work with an eclipsed moon, providing you could adjust it so it'd like be a circular polarizing filter, so you could turn it on and off essentially.
Yeah, I mean that's true. That's true of any lunar observing. I normally use an ND6 almost all the time, unless it's in a quarter phase or something like that. Margie, you have a question?
Just for clarification, so the most left image of the moon is the penumbral phase?
No, that's an umbral. It's an umbral, an approaching umbral, right? Because it's quite dark, so I can't imagine it would be penumbral.
So is there any penumbral in there? Is the one
No,
on the
Yeah,
there's
I would
none.
say the brighter side is probably still penumbral.
Okay, thank you.
Okay, go ahead, Kirsten.
There's
Here's
another one from Joe. Yeah,
yeah, another one from Joe.
2008.
Yeah, a little bit different again. I like the fact that he's shown the approach. Yeah, it's rising. Oh, that's the other thing. In I've seen many lunar eclipses, and that seems to be unique to every lunar eclipse. Like sometimes it's already up in the air and you see it. Sometimes you're waiting for it. I actually remember a time when we were up on the hill, and I think Chuck Filtness and I were looking, and we're trying to guess who was gonna see it first, because it was quite bright, and we were just waiting for it to appear. I think Chuck won.
Yeah, that's what happened here. We were observing it from Cattle Point, with 4,000 of our closest friends, and it rose out of the clouds, and it was quite late, like half an hour, three-quarters of an hour
Yeah,
before we could actually see it,
yeah,
compared to what the theoretical rise was.
yeah.
Because it was,
And you also see the bright reflections in the water too. So that's really nice too.
Very pretty.
Yeah. Go ahead. And
Oh,
and this
this
is
was such a cool shot.
yeah, John's really good at this. This is a time exposure, and but he captures the moment, the movement of the people on the land, and of course the stars. I love eclipses when they have stars in the background. This is very nice. Even though the moon is very small, it's kind of almost it's like an environmental shot, right?
And I guess what happened was he was photographing over time lapse, and then this family just kind of moved in and just created this ghost-like effect.
Mhm.
And here's a really nice one of the umbral stage from Joe in 2010. Shows it really well. Like the umbral shadow moving across the face.
A very deep shadow,
Yeah, very
being
deep
the
shadow.
being the umbral shadow. Yeah,
Yeah. Which I guess because the umbral shadow is so deep, it just really makes the lighted portion of the moon just glow, I guess, in a really
yeah.
extreme kind of way.
Now
And
Charles is no, I don't know if Charles is still a member or not. Anyways, he doesn't live here anymore. But Charles is always showing up with impossible shots, and this one he shot in Arizona, so it's not shot here. That was in 2011.
beautiful red color.
Yeah. Now the redness, like I said, really varies. Like sometimes I remember years when there have been forest fires adjacent to the eclipse. They're very red. Here's another composite shot. This time from John. I never noticed this before. There's a kind of like a replication. It's the lights that are on the terrestrial side. They're not anything to do with the moon, but they kind of echo the streak of moons. That's nice.
Very, very beautiful shot to illustrate the phases of the eclipse.
Yeah. I wonder if Kirsten, I wonder if this can be drawn. We could draw this.
Yeah, and
Another,
another one.
yeah, another one from John, from his backyard, I believe.
Yeah, yeah.
Oh, I have a story for this one. So this is 2019, and like I mentioned, often what happens is when the moon rises, you never know what state it's going to be in. So sometimes it's hidden in the murk. In this case, and I'm trying to remember where we were. I may have been at home. I don't know. But anyways, I remember the moon was this golden honey yellow, and it wasn't until it rose further that we would see the moon, and then see the umbral stage, and then totality, and near post totality. So this is a favorite of mine. Yeah, another composite.
Yeah, this
Hey,
one was really great. Like the labels, um, very, very helpful in terms of identifying the phases of the lunar eclipse and the corresponding
nice.
shadows and colors.
Yeah, very nice.
Yeah. And then last but not least, a beautiful shot from Wyman.
Yeah, Wyman's here. Do you have any comments, Wyman? I don't know if Wyman's still here. Let's see. Let's see if he's still here.
He's here. He's just
Oh yeah,
figuring.
I'm here.
Oh, do you have any comments, Wyman? Where were you?
I don't remember I took this, did I?
Well, it's credited to you.
It probably is actually David.
It's probably you. Yeah.
No, I don't think so. I remember.
Oh. Oh, I might have. I don't know. I don't recall.
Mm.
Oh,
But I
well,
think
it's
you've got that kind of blue tinge in this one too.
Huh.
Weren't you not using a super zoom camera for this one?
If I did, I would. I probably did, but it was not tracked or anything. Just possible. I took it on one shot.
If it's short enough exposure, yeah. If you had the ISO cranked up.
Yeah.
But this is interesting because it's so brilliant. This is one of the deeper ones.
Huh.
beautiful shot.
Yeah, it's nice anyways.
Just say it's yours, Wyman. That's great.
Take it. I'll take it.
Very, very lovely. Beautiful.
Yeah.
All right, and that is the end. So yeah.
Well, Kirsten, I noticed you said in your talk that it's one of it's a safe eclipse to watch, right? So what would you use? What are people's favorite tools to use? What do people use to watch eclipses with, lunar eclipses with? Any comments?
Binoculars.
Yeah, that would be my go-to. Yeah.
Yeah,
Ben,
small
you have
telescopes. Yeah.
small telescopes. Yeah. Ben, do you have a question?
Well, one of the questions was, shall I bring up my binoculars on Thursday? It sounds like I should.
Yes.
I just had some logistical questions. But we just drive right up there, right? There's no waiting down below or anything like that.
Lauri will answer that question, I think. Wherever Lauri is. Lauri, are you still there? Oh, she's probably cleaning up. No, there she is. There she is.
So David, it would depend on, I mean, we've got to have a pass to get in through the gate. So I don't
We
think.
do, but I think Lauri's just about to speak.
Hi. Sorry, what was I was just gone for a minute. What was the question?
Oh, just wondering the logistics of getting up there on Thursday. like I signed up and everything,
Oh, yes.
but do we have to wait down below like the gate and everything?
Yeah, you'll be allowed in, I believe, at 8:30. There will be commissionaires at the gate to let you in. So
Okay,
that's not a problem.
Just say hi, you're here for the eclipse.
Your name
Yeah.
will be on a list.
Yeah.
So
And what are
anybody
all the
coming in.
telescopes being used? Like, is it all our RASC ones or?
It will depend.
It'll be a mix. The center has telescopes. I'm likely bringing up a telescope. I actually told the class that if they wanted to bring up a camera, that I would bring some spare trackers so we could get those totality shots. The totality shots usually need to be done with a tracker. Otherwise, you have to really crank up the ISO. So if you want to have a really fine ISO where you have good detail, then you have to use a tracker.
Okay, question.
Yeah.
You know, when you see the edge of the shadow moving across the moon, is it 1 kilometer a second, or like what is the speed?
I don't know the speed. That's a good question. I didn't
thought
think you would ask that.
Yeah, no, I thought I read something. It was a tidbit like that. It was like 1 kilometer a second. You know, just to get a sense.
Oh, well, we could measure it and then
Yeah.
divide by the diameter, I guess. Figure it out, I guess. That's a good question, Lyman. I'll see if we can figure it out.
Yeah. It's so you know the relative speed of the Earth moving across. Well, I guess both are moving at the same time, right?
We're both moving, and
So
there is a lunar speed as well. Like we know about sidereal speed, which is speed at which the stars appear to move. Well, there's also a lunar rate as well,
Yeah.
slightly different.
Yeah, interesting.
Yeah, Randy would know probably.
Yeah.
Yeah, Randy would know.
Yeah.
Can a shadow move faster than the speed of light?
It is light, isn't it? I don't know.
Yeah, what's a shadow? Not a thing.
So Randy is going to be doing the citizen science part of the program, where he's going to be actually timing the craters with whoever wants to be with him at his house, and he will call out the craters, and people will be calling out the time for when it comes to exactly the half part of the crater. And then they'll keep track of all that and then send it into the whatever group is doing that. I'm not exactly sure which national group is that, but if they get timings from all over the place, they're looking to be able to do some really good science on this. Yeah, so we're part of that.
Yep.
Is the time daylight savings time?
It's adjusted. Yes, it's already adjusted.
Okay.
It's my stellarium is showing -7 right now, which is correct. It was -8 before.
Yeah,
Wade put the answer to the speed in the chat.
Oh,
Yeah.
did somebody look it up?
Wade put the answer in the chat.
Oh, okay.
Seems pretty fast.
Oh, interesting.
How fast?
It says an average speed of 1 kilometer per second, approximately.
Yeah, 1 kilometer a second. Interesting.
Hmm.
Hey, if so, from the moon, when they view the Earth, so you will see a corona of the sun.
Oh, that's interesting.
You should, wouldn't you? I think you would.
Oh,
But it won't be as sharp because you got the atmosphere, or will it? I'm not sure.
another question I can't answer.
Oh, well, maybe this time we'll get a photo from, because they are don't they have two spacecraft on the moon now? Yeah.
Randy mentioned that last week. Yeah.
But from the moon, the Earth will be a lot bigger than the sun.
Oh.
Yeah, you can see it.
Okay.
But didn't that one it wasn't okay, the last lunar landing?
You're right, it tipped over.
Somebody asked about the weather predictions, Reg.
Yes, Reg.
It's
Yes,
not
Reg.
entirely out of the question.
I was wondering how you're going to answer that.
Yeah.
Perfect
Thanks.
weather forecast.
Yeah.
It's the only night this week that we would have a chance.
Mm-hmm.
Yeah, yeah. I'm optimistic.
Looks good for Dave.
Oh, yeah.
Okay, well, that was really an awesome discussion about that. And maybe Lauri, this might be a good time just because we're on the topic of the eclipse, just to talk about the
Yeah.
Lunar Star Party and some other updates up at the center before we move on to the other items.
Okay, so just very quickly, there will be a Lunar Star Party. I believe people are starting to come in at around 8:30. As we said, the penumbral starts at 8:57. And then the umbral starts around 10:09 or something like that. So we're going to be doing a couple of little presentations, just our little group. We're going to be doing some presentations in the auditorium for anybody who would like to see those. We've got the planetarium open. There will not be dome tours that night. And then if it's nice, then we're going to be having invite people to come up with their telescopes and show everybody. We have about 150, 170 tickets, or our registrations have already been put in for that night. Now, obviously, if it rains, people probably won't come up as much, but we'll just kind of go along. It's going to be one of those flexible nights for whatever is happening kind of outside and what we can do with that. We will stay probably through till I believe 1 o'clock. I think that is the time that we've been given. If people who are members of the VCO would like to stay up longer, they can stay up as long as we know that. But we'll be probably shooing people off the hill about 1 o'clock. I may not even make it till then. I may be gone before then, but that's what is happening. So hopefully come on out if it's nice, except for Dave Payne, of course, who doesn't want to come. Yeah, so blue. Okay, anyway, yeah.
Can I ask you, Lauri?
Yes.
Yeah. I'm gonna be there obviously at 7 to 9 because of the Nova thing.
Yeah.
So am I supposed to get a ticket as well?
No, the people who are part of Nova, their names have already been put into the mix.
Okay, thank you.
So it's okay. Yeah.
You throw me out.
Sorry, did we want to, the question that was asked earlier about the funding update, did we want to give a quick update on that?
Sure. Yeah. So we were successful in getting what's called the Pacifican grant from the federal government. This is given for groups of people who are doing mainly really tourism. I believe, in this regard for the all across Canada, and we put in to have some money so that we can increase the tourism part of our program. Like right now, some of you may know that we do community tours and that kind of thing during the time we're open, during the summertime, during the day. And we also do cruise tours. For the cruise ships come in, we do a very quick turnaround on them. They come flying up the hill. We do a tour, and then they go back down, and they have to get back on the ship again before they leave. So it's a fast tour, but it's quite good for us. We had I can't remember the exact number that we had over the year, but we did have quite a lot of cruise tours, and the number of people that came in, and it provided some very needed funding for us. So now what we're doing is using this money that is coming into us to help us to make a full tourism program where during the day people will be picked up downtown in buses and brought up to the center in order to have full tours of the center as well during the day or in the evening, that are just simply not coming off of ships, but just everybody else, like happens at, for Butcherd's Gardens or any of the other kinds of venues that are around town. We're hoping to be part of that. So this is very specific. The money is for for marketing and branding and getting the program going. And we have got some people who are contracted to do some work to help us get all of that ready. We're going to be putting this into a we have to go and present this to the tourism group to say, hey, come on tours with us. And we have to get all of that ready. So we're going to be starting to do a little bit of piloting some of the programs this summer, but we're really looking to have it done for 2026 is when the whole thing will really start. This is to help us with our main mandate, which is the school programs and the educational programs. The school tours do not bring in the amount of money because we're trying to keep our fees really low for the schools so that they can be accessible. And in fact, we just kind of pressed the button today for another grant that will be from the Victoria Foundation in order to keep that to keep our funding going for the school program. But these are very separate. These are very separate programs, so one doesn't really affect the other at this point. So we're looking really hard. Ben Dorman, bless his heart, has done a huge amount of work over the past 6 months or 8 months in order to get a lot of this going, and we're hoping that this will work quite nicely. Kirsten, is there anything else that you think should be added there?
The only thing, Lauri, that I can add is great, is just there's an actual official announcement.
Yes, yeah.
The federal government, it's actually Pacific Can stands for the Pacific Economic Development Canada Department of the federal government, and they've put out a formal news release about it, and they actually gave it was a total of about $4.8 million to a total of 24 organizations. And I think it's over 2 years or 3 years. It's over a period of a few years. But the published amount of the grant that was given to the Center of the Universe was around about $165,000. So and that's again over a number of years. But it's intended for new programming, just like Lauri was mentioning, new programming specifically designed to increase tourism and make the Center of the Universe kind of just a very viable, attractive tourist attraction in Victoria that will have increased revenues to support its nonprofit functions. Yeah. Yeah. So it's a very exciting time. But it's kind of a watershed moment because it's a lot of money. And so there's like new staffing and that'll be working on marketing and new programming. And so it's going to be a whole new kind of era of management, to look into that kind of funding. So yeah, but it's very exciting.
Hey, Lauri.
Yes.
Have we ever approached Hallmark and make them shoot a movie there? Movie?
Wouldn't that be great?
Well, when they shoot a movie, is it like it's only like a 3 or 4 day, right? You compress it.
There actually has been a movie shot there already.
Yes, yeah.
Oh,
actually,
really?
there's been about 3 actually.
Yeah.
One of them, which is what was it? The one with the dogs.
Yeah.
Oh,
Super Pups or something like
Super
that.
Pups, Super Pups, yeah. And
Oh,
that was what. And there's another one that says he's just been released that is about Agatha Christie, who came up to the center and visited the center before she started writing her books. And
wow.
there is a movie about that that's just coming out. And we also have got some historical ones that have been done. But you're right, we should kind of put ourselves in. Mind you, see, we don't do this ourselves. This all has to be done through the National Research Council. So it's
Yeah.
a federal thing. So, but a
Oh,
good
yeah.
idea.
But anyway, send us the link or tell us about it so I can search for it on YouTube. Yeah, I'm just intrigued.
Yeah,
Yeah, actually, Super Pups, you can actually see the dome and you see the center of the universe, everything.
Oh, cool.
Yeah, it's kind of fun.
Great.
Okay, well, you'll hear a little bit more about it. So it'll come through.
Okay.
Yeah. It doesn't mean we're out of the woods, though. There's a lot riding on this, so we need to be really very, very careful with what we're doing.
Mm.
Yeah. So, okay, that's the end for me.
Thank you so much, Lauri. Okay, Natasha, you have an item?
Yes, thank you very much. And congratulations on the funding and your presentation as well. So this is moving into a completely different topic, but it's related to astronomy. And I'm just going to move this over here. What I'm interested is public outreach and communicating astronomy to a wider audience. And one of the ways we do that is through cross-disciplinary activities like we did with Coloring Space and during the International Year of Astronomy. And so I just wanted to share, and it's quite likely many of you know about this quilt already. It was created between 1876 and 1883, and I'll show you a larger version of it. It was made by a science teacher in Iowa, Ellen Harding Baker, and she used it to illustrate her astronomy lectures. It's about 7.5 by 9 feet, and it's at the Smithsonian at the National Museum of American History. And she went to Chicago to the observatory there to view sunspots and the comet, which was they're pretty sure it was the comet of 1874, C 1874 H1. So this is a larger view of the quilt. I can put a link to this in the chat. And so it shows the sun at the center, the 8 planets of the solar system with the indicated orbits around the sun, as well as the asteroid belt. And the myriad of stars that exist beyond the solar system are also shown. Galilean moons of Jupiter, as well as the moons of Earth, Saturn, Neptune, and Uranus are included. And the upper left of the quilt features the comet, 1874. And there's 3 close-ups of the quilt here. There's a nice one showing the comet. Another one. And this one here. So that's it really. It's very quick. I will put the link in the chat. And there are a couple of other venerable quilts that have a theme of astronomy, and I'm starting to put together a little collection of them. So I'll keep you posted.
That is brilliant.
Thank you. It's fun.
Are you a quilter, Natasha?
No, I'm not. I do have a background in art, but I admire ways of communicating subjects that, people who might be a little bit leery about exploring the world of astronomy. These are ways of drawing them in. So that's more my perspective.
That's what you did before overhead transparencies.
That's right.
Oh, thank you for sharing that. Okay, Dave Payne, you've got some photos to share with us.
Yeah, I'll be real quick here. There's just a couple of photos I've taken recently here on Maui that I thought people might be interested in. So let me share. So it was a handheld phone I took this with, but it was when the moon was kind of conjunct with Venus.
Oh yeah.
So they were conjunct in terms of elevation, and you can see the relative position of the sun. You got the soup bowl lit up on the moon, and it's the lower part of Venus, although a bigger part of Venus is lit up.
What was the date, Dave? What was the date? Do you know?
I can't remember. It was about a week ago.
Week ago. Okay.
And then something that I really liked about it was over the water,
Oh
so
my.
they both cast their own reflections across the water. There was another time when the moon was absent, and I remember seeing my Venus shadow, which was kind of cool. But it does highlight the misalignment with the moon's orbit and the ecliptic.
Was Dave, was your impression of them both being like little brother to the moon? Like was Venus so bright that it just looked like a little version of the moon?
From your eye, yeah.
Yeah.
It just looked like a point, but when you took a picture, you could see that it was the lower half of Venus pointing basically straight down to the sun. That was lit up. And then something I had never seen before, just a curiosity, was a rainbow, which I've seen before, but this was a rainbow, and right there is the moon. So I've never seen the moon.
And a secondary. You have a secondary as well.
Yes. And I've got a zoom in shot of that. Here's a bit of a zoomed in view of the moon in a rainbow. It's just the moon has to be in the right place. It has to be visible during the day.
Yeah.
And it can't be clouds, but there has to be rain. So it's quite remarkable. I guess the rain is so fine here that it blows a long way in the wind, and so you can actually get blue skies offsetting. Final one, when I zoom in, you can barely see the rainbow at the bottom. There's the moon at the top.
Whereabouts are you, Dave?
I'm on Maui.
Okay.
Yeah. So this was just taken a couple of days ago. So.
Yeah, nice spectrum.
We're all drooling, Dave.
Well, it's nice to have clear skies, which is
wow.
And winter's late at home, so
I take it you weren't allowed to take any astro gear.
Spring's late. No, this is just from my phone.
Very pretty.
Okay, I'll stop the share.
Thank you.
Thanks.
Very nice.
Okay. Anything else from anybody tonight?
Is Chris with us? I guess Chris isn't with us. No, he's not. I thought he could tell us something about the defunct lander.
I had a general question just from people that go down to Cattle Point to observe and take pictures.
Mm-hmm.
Is there a certain area you go and stand in, or like you use down
Do
there?
you know?
'Cause there's a lot of headlights.
Do you know where the boat launch is?
Yeah.
Okay, so if you're coming from the city, and you're driving in, you'll pass the boat launch,
Mhm.
and there actually is kind of like a bulletin board specifying that it's an urban star park. We're kind of in between the boat launch and those bulletin boards, and we hang back. And what the visual observers do is they kind of use their cars to kind of block and barricade the area, and then
Gotcha.
they tuck themselves behind. As far as the imaging people are concerned, we tend to be on the side that's closer to the bulletin boards, and we hang back. And then we usually have our cars in front, so it blocks it somewhat. And but a lot of people are using narrowband, so it doesn't really matter.
Yeah. Okay. I was just curious. I drove through there the other day and I thought, well, I wonder where you guys set up. And I was like,
Yeah, that's where we set
you get
up.
a lot of headlights.
We
So it's
do,
like,
we do. But
yeah.
there's some nights when we don't get a lot of people, and it's okay. And a lot of the diehards tend to stay really late, and most people disappear by then.
Mhm. Thank you.
But Kirsten, do you want to make some comments? I know Jill's not here, but maybe some comments about Kettle Point.
Yeah, I think it's fair to say that despite kind of the proximity to the lights from Victoria that can be visible kind of in that southwestern um, direction, it's still it's a really great place. Particularly, I think the eastern direction and southern direction in the summer. It's just you can't really beat it for Victoria unless you go up to a place like the VCO or further away from the lights of the city. But yes, the headlights for sure they can be an issue, but it's kind of worth it. It's worth it. Yeah.
They come and go anyways, so it's not troublesome for visuals, and even for imaging. Well, you ruin a couple of shots, you just
Yeah.
toss them away, right?
Yeah.
Yeah. And
Um, Kirsten, I noticed Susan was asking about this Wednesday at UVic.
yeah, yeah, that's oh, and thanks, Megan, for your comment. Yeah,
Oh
Megan,
yeah.
who does some imaging down at Cattle Point, and yeah, well, it's good to know that the headlights don't really affect the imaging that much.
Hmm.
But yeah, sorry, I've just got a hungry cat that's wanting his dinner. Um, yeah, this Wednesday up at UVic, we have our monthly meeting starting around 7:30. And we are fortunate to have a guest speaker who is going to be talking about the Europa Clipper. So I'm happy to say that that will be a very interesting presentation, and I'm just going to quickly just make sure that I get the name correct. Tess Grindley. And she is a graduate student or undergraduate student in physics and astronomy. So she is going to be doing an update. I've seen this presentation before up at the center, but just after the Europa Clipper was launched late last year. And so hopefully she'll give some updates around sort of its recent progress around it's just done a kind of a gravity assist flyby at Mars, and it's actually on its way back to Earth, interestingly enough, to pick up another gravity assist through Earth. But she's going to talk about Europa, the Europa Clipper mission, and what the objective of that mission is around determining the potential for life around that moon of Jupiter. So looking forward to that. So 7:30 UVic, and then we'll have sort of the usual coffee and cookies after that.
So it's going to be a busy week.
Yeah, busy week. Okay. Well, thanks everybody for coming out tonight and being on this, and to everybody who presented and participated in the call. Really appreciate it.
Good job, Kirsten.
Good job. Yay.
Made it through. Thanks everybody.
Okay. Bye for now.